Stanford University.
All right, well, welcome to lecture number 3 of CS193P Fall of 2011. I'm going to dive right into the stuff today because we got a full lecture for you. You've done the walkthrough hopefully by now, or at the very least you saw me do the walkthrough last week, and maybe you've even done the homework, which would be great. Okay, if you are, you're ahead of the game. I'm glad to hear that. But before I go and talk about a whole bunch of new stuff in Objective-C, I really want to briefly go back through the walkthrough and list a bunch of things that you should know by now. Okay? So as I go through this list, if you're like, oh, I don't know that, you want to make a note. Okay, and say, I better go back and look at the walkthrough or figure that out. If you haven't done the walkthrough, you haven't done the homework, you still should know most of this stuff from my demo last Thursday, but you might be fuzzier on it. Okay? So what did we learn last week? Well, we really learned things in 2 categories. We learned a lot about Xcode 4, and we learned a lot about Objective-C. So let's talk about what we learned in Xcode 4 first. You learned how to create a new project, right? Just that create button in the splash screen. You can also create a new project from the file menu by saying new project. Okay? You learned how to show various files in your project, either by going to the navigator, that thing on the left that shows all your files, or whenever you're showing a file, you can go to the top of it, the little bar, and click on the name of the file that's being displayed and use that as a pop-up to switch to another file. So you learned that. You learned how to kind of arrange Xcode's user interface, getting rid of the project navigator, bringing out the palette of objects and the attributes inspector, and splitting your view into 2 windows using the assistant editor, and bringing up the console and the debugger at the bottom. So you learned all how to do that. Obviously, we learned how to drag objects out of the palette in the lower right-hand corner. We dragged a bunch of buttons out. We dragged a label out. So you learned how to do that to build your view. Then once you had your view built, you learned how to use the control key while dragging to connect up those objects in your view to your controller by dragging directly from the objects into your code. And that's both for hooking up outlets so that your controller can talk to your view, and also hooking up actions so that your view can talk to your controller. You learned how to mouse over the little round dot that's in the gutter to the left of your controller code to see what an outlet or an action is connected to. You can also right-click on that, and you also can right-click on objects in your view. Okay, that's covered in the walkthrough. We didn't do that in the demo, but you can right-click on objects in your view, and it'll bring up a little window. It shows you all the connections. Sometimes if your application's not working inexplicably, you're touching a button and it's like target action is not being sent, it's a good idea to go and right-click on the objects in question in your view and just make sure that the connections are what you expect. And when you right-click, bring up that window, and you hover over with the mouse, again, it'll show you what things are connected to what. You learned how to get help by using the Option key and clicking on text, or Option double-clicking to bring up the full documentation. You learned how to run your application in the simulator, obviously. You learned how to click on the yellow warnings and the red errors. And you know, sometimes you have multiple errors on one line, and if you click on the little yellow or red thing, then over on the right-hand side, it'll have a number like 2. There are 2 warnings here, and you can click on that. And by the way, if that warning is so long that it doesn't fit on one line, which is common, you can mouse over a warning, and it'll show you the full warning in a tooltip. Okay, I don't know if we showed that on Thursday. Pretty sure it's covered in the walkthrough, though. You learned how to create a new class, Calculator Brain, right, our model. We created that by going to the new file item in the file menu. And we showed in the walkthrough, I don't think we did this on Thursday, but we showed in the walkthrough how to use the tabs, how to create tabs, browser-like tabs in Xcode to kind of arrange your different things. You could have your model in one tab, you could have your controller and view in another tab, etc. Okay, so that was Xcode. Learned a lot there. Hopefully you feel like you learned all that. Then there's a bunch of Objective-C stuff we learned. All right, you learned how to define a class's public API in its header file and its private implementation in its .m file. And you also learned how to create a private interface, private API basically, in your implementation file as well, using that @ interface class name parentheses, and then you can put private properties, private methods there. You learned how to create properties in general, right? Both properties for primitive types, like users in the middle of entering a number, which was a bool, and also properties that are pointers. right? Pointers to an object like the operand stack, that was an NS mutable array star, a pointer to an NS mutable array instance. You learned that you're supposed to put non-atomic in all your property declarations. You learned where strong and weak go. I'll cover strong and weak again today just because it's such an important concept, but you learned that pointers, properties that are pointers, need to have strong or weak specified in them. You learned how to use synthesize to create the setter and a getter for a property and also to create a backing instance variable. And you learned that you always want to put equals underbar property or equals IVAR underbar property name or something so that the name of the backing instance variable is not the same as the property because that leads to some subtle problems, which people who have been on Piazza, there was actually a good question about that where we talked about what the subtle problems there are. You learned that pointers to an object kind of come in two varieties. There's ID, which is pointer to any object, pointer to unknown object type, and then there's statically typed pointers like UI button star, NS string star, UI label star, where those are pointers to that kind. And you know that there's no difference between those two except for that the compiler can help you find bugs if you statically type. So we should statically type whenever possible. But on Thursday, we're going to learn when we might actually want to use ID. Okay, and say in the lecture today, I'm going to show how we deal with the fact that something's an ID. Let's see, you also learned how to define an Objective-C method, quite a few actually, push operand, colon, pop operand, so you learn private methods, public methods, some that take an argument, some that don't, et cetera, some that return something, so hopefully you got a good feel for that. You learned how to declare local variables. The first line of code we typed was ns string star digit equals sender current title. So that's a local variable in a string star digit, so you definitely learned that. You learned how to call Objective-C methods with open square brackets, pointer to an object, and then the method name with all the arguments mixed in. You learned how to invoke setters and getters for properties using dot notation, which is just the same as the square brackets thing in terms of how it works, but just a different syntactic sugar, a different looking syntax. And you learned how to lazily instantiate an object, right? Like the calculator brain we lazily instantiated in our controller, and the operand stack we lazily instantiated in our brain. So we've got a couple examples of that. More Objective-C, you learn to wrap a primitive type, a double in our case, in an object so that you can put it in things like an array. You learn how to use NSLog to log things to the console, great debugging technique. Creating a constant string using the @ quotes. Don't forget that @. Luckily, the compiler will usually find, will give you a warning if you use no @ quotes, because that'll be a char star, and there's almost nothing in the API that uses a char star, so the compiler's going to be able to warn you. You learned a little bit of how to add and remove an object from a mutable array. You only removed the last object, but we'll show more about mutable arrays today, hopefully if we get to that. If not, certainly on Thursday. You learned a little bit how to create an object with alloc init. Okay, you allocated that mutable array by doing alloc init, and you actually allocated your model by doing calculator brain alloc init. We're going to talk more about that today. You imported a header file of one class into another. You imported your model into your controller, which is common. 100% of the time you're pretty much going to do that. And you learned a little bit about strings, how to create a string by asking another string to append yet a third string onto it and give you a new string, which is the result of that combination. And then you learned how to create a string from scratch by asking the string class to do string with format. And I'm going to talk a little bit about class methods and instance methods because I really waved my hands a little bit in the walkthrough on that, so today we're really going to talk about it. So you can see there's a lot of stuff, okay? You've learned a lot of stuff in just the very first week, but if these things are a little fuzzy to you, go back to the walkthrough, or if you haven't done the walkthrough, definitely do it, and hopefully by the time you're done with the homework assignment, you really know this stuff. So any questions on all that? Okay, awesome. All right, so today we're going to talk about Objective-C, okay? All day long, so Objective-C, all the time today. First, I want to go back and go a little more depth on something we talked about last week, which is properties. Properties are very important. That's why I'm spending a little more time on it. Some people have asked the question, why do we have properties? Okay? In other languages, I'm used to just having instance variables. What is all this properties business? Okay? The number one reason that we have properties is for safety and subclassability of our instance variables. Okay? if we're going to allow someone to subclass us, then if they're going to start mucking with our instance variables, we want to be able to be involved. So if they set our instance variable to something, we might want to bounds check it or make sure it's not going to break us. So you see how that provides safety for us? So that's the number one reason actually to do this. But it also provides, and this is a close second reason, kind of a valve, a choke point through which we can do lazy instantiation, which you saw, updating of the UI, right? If you have some object that is displayed on the screen and you change some attribute of it with the setter, it'd be nice to mark that that view needs to be redrawn, all right? So that's a great place to put that. Consistency checking, remember in the thing we did on the first day of class, I checked to make sure the speed wasn't greater than the speed of light, right, in the setter. So that's another great reason. So properties have a lot of really valuable things to them that we need. So we don't want to be accessing our instance variables directly. But let me say something about instance variables. Two things. One, as people have asked, is it required to have an instance variable for your property? And the answer is definitely not. It is not required. And how would you do that? How would you have a property that had no instance variable? You don't use @synthesize. You create the setter and getter yourself, right? Because if you're not going to have a backing instance variable, you got to basically manufacture or calculate that property yourself. And we're going to do that on Thursday, just so you can see what that looks like to have a property that does not have a backing store. And then there's the other question, the other way around, which is, can I have an instance variable without a property? And of course the answer is yes, you can, but I'm not even going to show you that syntax. Okay, I don't even want you to think about that right now. I want you to use properties anytime you think an instance variable, go get a property. Okay? Later in the course, if you're good, maybe I'll show you how to do instance variables, but for now, let's do properties. And how about dot notation? Why dot notation? People say, why do we need this thing? Well, no, probably one of the most important reasons, it looks nice. You remember the line of code, the second line of code actually in our walkthrough was self.display.text equals open square brackets self.display.text string by appending string digit. Well, if that self.display.text was nested square bracket calls, you'd have an awful lot of square brackets on that line, and it could be a little hard to follow. Whereas self.display.text is very easy to follow, so it's prettier. It also makes access to properties stand out a little bit. Okay, we just want to know when we're writing our code and we're reading other people's code, it's a little nice to know, oh yeah, this is not just a method call to a getter or to a random method, it's a call to a getter. And we use dot notation. It kind of stands out some. There's also a synergy between dot notation and C structs. All right, everybody here hopefully knows C. You took C++, I guess. Is that CS106B is C++? I don't know, CS106A, some B or whatever. So you know what C is, you know what a C struct looks like, you know that the members of a C struct you access with dot notation essentially. Just to give you an example of how this synergy works, I created a little code example. So I have a struct here, a C struct that I've type def called CG_point. It has two members, x and y, two floating point numbers. So this might be a point on screen, let's say. That types, like class names, structs, any enumerated types that we create, we capitalize in Objective-C. Okay? Capitalize types. We do not capitalize other stuff. We don't capitalize property names. We don't capitalize method names. We don't capitalize local variables. Okay? So please stick to that naming convention. It makes it a lot easier for everyone to read your code if you stick to that naming convention. Everyone understand it? So since CG_point is a type, it's a type, a struct, the type def of a struct, C struct, we capitalize it. All right? Okay, so my little example here is I've created a couple of classes here. One called bomb, which has a property, which is a C struct. And yes, you can have properties that are C struct. And notice it's not a pointer to a C struct. It is actually a C struct. Okay? And then I have another class, ship, which is got three properties, a width and a height, so it's a rectangular ship, and it's got a center point. And so I want to write a method, gets hit by bomb, which is sent to the ship. Say, if I drop this bomb on you, will you be destroyed? So it returns a bool as to whether it's going to be destroyed. Okay? So what would that code look like? Here's a possible implementation, or a skeleton of it anyway. And all I do is I calculate the left edge, the right edge. I'd have to calculate the top edge and the bottom edge too. And then I just return whether the bomb's position is between those edges. Okay? So the key thing to notice here is look at that dot notation. Those two dot notations that are highlighted, that's accessing properties. You see that? Self dot center, that is the ship accessing its own center property. And then down at the bottom, bomb dot position, that is accessing the position property of the bomb star argument to this method. Everyone got that? And then these other dots over here, that's accessing the C struct. Okay, whether it's the self-center C struct or the bomb position C struct. So do you see how the dot notation and C structs kind of play nicely together? If I want to know the x position of the bomb, I can say bomb.position.x. All right? So that's part of what I think the motivation behind making dot notation look this way. All right, everybody got that? All right, on to strong versus weak. So this is a very important concept. It's a lot easier in iOS 5 than it was in iOS 4, but still, I want to make sure you all understand what's going on here. So strong versus weak, these are, strong and weak are descriptions or attributes that we have for pointers. Okay? Now, when we do an @sign property UI button star or something, that's a property is a pointer. So it needs to be strong or weak. That's why we say @sign property, parentheses, non-atomic, strong or weak. So just to be clear what the difference is between a strong pointer and a weak one. All right? A strong pointer means keep the thing that, and this is for objects, sorry. Strong and weak is for pointers to object, not pointers to arbitrary memory, which we almost never use in iOS. Right? We're almost always using objects. So strong means keep the thing that this points to in the heap, the object that this points to, keep it in the heap. Don't deallocate its memory. Keep it in there, okay, until I stop pointing to it with this strong pointer. Okay? So in other words, I'm strongly pointing to that thing. I want it to stay there. And the only way I won't point to it anymore is either I set this pointer to nil, obviously it's not pointing to it then, or I get thrown out of the heap. Right? So all my pointers are no longer pointing because I'm gone. I got thrown out of the heap by it. So no one strongly pointed to me. So now I'm gone. So obviously all my strong pointers no longer point there. Okay? So that's what strong means. Weak means only keep this memory in the heap as long as someone else, at least one other person, has a strong pointer to it. So this is, I'm pointing to something I'm not really that interested in. It's okay if it went to nil. And in fact, weak also means if no one else points to it and you throw it out of the heap, set my pointer to it to nil. Because I certainly don't want to try and access my pointer and I'm pointing to something that's been thrown out. Everyone understand that? Okay? So that's strong and weak. It's as simple as that. Now, in iOS 5, one thing about weak, that only works if the application is running on iOS 5. Okay? Strong and weak, you're developing in iOS 5. You're using the iOS 5 SDK. It supports strong and weak. But the weak, the nilling out of the pointer when the thing gets thrown out of the heap, that only works on iOS 5. That's in the runtime. That setting your pointer to nil happens in the runtime. Okay? So if you're building something in iOS 5 and targeting it to run on iOS 4 devices, you can't use weak. You can't rely on this nilling thing. You'll have to use strong pointers and you'll have to set them to nil yourself to make sure that things get thrown out of the heap. Okay? So what is this? Is this garbage collection? People are saying, oh, it's great, we've added a garbage collection. And the answer is no, this is not garbage collection. Okay? This is reference counting. Okay? We are keeping a reference count of how many strong pointers there are or something in a heap. And when that count goes to 0, no one points strongly, we immediately free it. It's not like garbage collection where you're making passes through the heap every once in a while, who knows when, indeterminately, to find out if no one points to something and then cleaning it up. Okay? Garbage collection can have bad behavior in that it's not controllable by you, the programmer. Those sweeps are happening outside of your control. This is completely under your control because when that last strong pointer is gone, it immediately gets freed. Immediately. Okay? Not after a delay. Now, we've talked about strong and weak pointers here in terms of properties, but things like local variables are strong pointers. If you have like NS_string star digit equals sender current title, that's essentially strong. But of course, that variable goes out of scope when the method is over, right? It's a local variable in a method. Once that method is done, it goes out of scope. Now that strong pointer is not pointing to that thing in the heap anymore. And if that was the last strong pointer, then it would get cleaned up. It's beautiful, all right? How does this all work? The compiler is essentially adding code kind of, to count these references for you, right? It's counting how many strong pointers there are. And when it gets down to 0, it frees it. Okay? Question?
So if you're developing on iOS 5 but targeting lower devices, so do you have to go back to retain release cycles again?
So the question is, if you're developing under iOS 5 and you want to be targeting an iOS 4 device, do you have to go back to the old way of manually doing your own reference counting? And the answer is not necessarily. Okay, you don't get the weak pointer setting behavior, but you can still do strong. Strong works fine. It's really outside the scope of this class right here to talk about how you would develop for back towards the older thing there, but just understand that that's something you have to think about. Okay? You're going to have to look into how to do that. So I got a lot more to cover today, so I can't answer that question, unfortunately. Some people ask, do I find out, does my object get notified when it gets thrown out of the heap? The answer is yes. You get this method dealloc, but you probably, in this class, you're probably not going to do anything in a dealloc. Dealloc is so late in the game, okay, you are already almost out of the heap. Okay, like the next line of code after this is you're gone. Okay, you don't even have any memory. So you can't really do much in here. You certainly can't touch any of your instance variables or anything like that, any of your properties, because you're going to be gone in a second. So I think the answer here, this dealloc used to be important in iOS 4 when you had to manually manage your memory, but now dealloc really not important. Don't worry about it. Yeah?
In the documentation I read there's something called release.
So the question is, in the documentation I heard there was something called release. Okay, that's iOS 4. We don't do it in iOS 5. Okay, release. If you call release, it's probably compiler won't even let you call release probably in iOS 5. Okay, you should not be calling release or retain or auto release or any of those memory management things. iOS 5 gets done for you. Okay. All right, nil. I'm going to blast through nil. I think everybody here understands nil. Nil just means you got a pointer and its value is 0. It is actually 0. Okay, nil means the pointer is 0. It does not point to anything. All instance variables, in other words, the backing things that @synthesize creates, they all start out 0. So all your instance variables start out nil. If you want your any property that's a pointer to point to something, you got to call the setter of the property, or you got to do lazy instantiation like we did in your getter. Okay, but somehow you got to set it. It doesn't synthesize. All it does is make room for the pointer. That pointer starts out nil. You can implicitly test for nil, like we did in the walkthrough. We said if self.user is in the middle of entering a number. We didn't say self.user is in the middle of entering a number equals yes. Okay, we just implicitly tested it. That's very common to do. And as I said before, sending messages to nil is perfectly fine. Doesn't crash your program at all. Actually executes no code. If the message you're sending returns a value, then it will return 0. Okay? Except this one thing you got to think about. What if your method returns a C struct? Okay? That case you have to check for. Because when you have a method that returns a C struct and you send that method to nil, you get back an undefined C struct. It could be anything. It's being passed back on the stack, right? So it could be stack junk or it could be anything. But you can't rely on it being any particular thing, okay? So if you have a method, like maybe I have a getLocation method that returns a CG point struct, I have to be careful here to make sure obj is not nil and handle that case separately. Everyone understand what I'm saying? Okay. All right, bool. I think you understand bool. No is 0, yes is non-zero. We don't use true and false, we use yes and no. There probably is true and false defined somewhere in all those header files, but we use yes and no. Okay? And we also implicitly test it a lot. Right? All right, instance methods versus class methods. Yeah, question first.
I realized that there is a bool type with capital with small b-o-o-l.
Yeah.
And I don't know what's the difference.
Yeah, so the question is it says, hey, there's a lowercase b-o-o-l in there too. Capital B, capital O, capital O, capital L, okay? That's the bool. Just use it, all right? Simple. All right, instance methods versus class methods. So this is not really very confusing, but for some reason, people get confused. And I'm not sure 100% why, so I'm going to go through, and on the left-hand side, I'm going to talk about instance methods, and on the right-hand side, I'm going to talk about class methods, okay? So that we can compare them directly, all right? They're quite different. Before I get into it, though, I do want to use this opportunity to point out again the difference between structs, C structs, and objects. Notice this method, this instance method, drop bomb at from, has one argument that is an object, and it says bomb star, and has another argument which is a CG point, and that does not say CG point star. Okay? So that point is being passed on the stack, passed right in line there. Okay? Whereas bomb star is being passed via pointer. That's because all objects live in the heap. Almost no C structs live in the heap. There's some, but 95% of C structs in iOS, we pass them around on the stack and allocate them locally on the stack. Everyone understand what I mean by that? Stack versus heap? Hopefully, computer science, 190 something people understand the difference between the heap and the stack. But the bottom line is you have pointers to objects, you don't have pointers to C structs usually. Okay, so I'm just time out from this to say that. Okay, so let's look at these two. So instance methods start with a dash. You see they have the dash on the left. That's all we've defined in the walkthrough is instance methods. Class methods start with a plus. Okay, so you can see some examples on the right there. Instance methods are normal everyday methods like you're used to in all other languages, okay, in Java and all that. They're instance instance methods. You send these messages to instances, to objects, and they implement them. So normal methods. Class methods are sent to the class, so they're not sent to an instance, and they're usually for creating objects or just utility methods, kind of global to a class methods where you're trying to find information that's relevant to that class, but you're not trying to send a message to a particular instance that's doing anything. Okay, so that's the difference. The calling syntax of the two is similar but different. They both start with a square bracket, but the first thing after the square bracket in an instance method is a pointer to an instance, right? Because we're sending a message to an instance. Everyone know what I mean by instance? Any questions about that? Instance just means an object, an instance of the object. And then we send the method. Whereas the class method, after the square bracket, we put a class. Okay? Now, there's two ways to specify that class, and I'm going to talk about both ways here. The simplest way is just to put the name of the class. So here I have two class methods, ship mothership, which probably gets the one and only mothership and returns it, so it's an instance, but it's not creating a new mothership every time, it's just shared. And then I also have something from our walkthrough, result string equals ns string, string with format. So I'm sending string with format there to the ns string class. I'm not sending it to an instance of an ns string. I'm sending it to the class, and that's actually creating an ns string instance for me. Okay? So that's one way to specify the class in the class methods. The other way is you can send a message to an instance called class. There's a special method that you can send to an instance called class, and it will return that instance's class. And then you can send class methods to that. So for example, here we have ship class do something. So do something is a class method. Ship is an instance pointer, a pointer to an instance of a ship. Class is a method we send to the ship to get its class. And then we can send it do something. Everyone got that? So those are the two kind of ways you can specify what class you want to send the message to. All right? Inside your implementation of an instance method versus a class method, self and super are slightly different. Okay? In an instance method, you all know what inheritance is. When you send a message to self or super, you're actually sending a message to yourself. Right? If you say super, though, you're using your superclass's implementation. You're still sending it to yourself, but you're using your superclass's implementation or their superclass implementation using inheritance, go up the tree. Whereas if you send it to self, you're using your own implementation. Unless you don't have one, then you'll inherit one. Right? Everyone understands inheritance there. So that's normal in instance method. In a class method, self means other class methods. So when you send a message to self inside a class method, you can only send class methods. Right? So there's no instance. Self is not an instance. It's just the class. And the super, same thing. You're sending a class method, but starting with your superclass's implementation. Question?
When do you use
When do you use?
commas versus named arguments? Commas versus named arguments. So right there, you're passing in a second argument to string with format.
Oh, okay. So good question. So the question is, you see in string with format, I've got a comma and then result. When do you use the comma versus the named arguments, right? Something colon, something colon, something colon. And I'm sorry, I should explain that. The comma thing is when you have an indeterminate number of arguments, okay? And string with format like printf, you know, the format string could have any number of percent whatever's in it, so it can take any number of arguments. So like nslog takes that. String with format takes that. So that's what that means, okay? Sorry, that's a very, very good question. All right, so that's the difference between self and super and class methods and instance methods. When do you use an instance method? Pretty much all the time. When do you use a class method? Usually when you're looking to create an instance, or you want to get a shared instance like mothership, or you want to get some kind of utility information about a class. Okay? So that's the difference between those two. And on Thursday, we'll create some class methods, so we'll see what that looks like. Here's a whole bunch of examples of methods here. Question?
Can classes have properties or instance variables?
Very good question. So the question is, can classes have properties or instance variables? No, they cannot. That's the whole thing of an instance. An instance is a storage area for instance variables and properties, and the properties and instance variables as well. So a class, since it's not an instance, it has nowhere to store that stuff, so it cannot have any. Okay? Now, it's C, so you could have C statics or other things, but they'd be global to your class, right? To the file or whatever. So here's some examples, like this one at the bottom. See, there's a class method that just provides some information. So it might be in ship. You might be able to ask the ship class, please tell me the yield for a photon torpedo of this type. Okay, I'm not asking a particular instance of a ship, what's your photon torpedo yield? I'm saying, if I had a photon torpedo of a certain type, what would be its yield, right? It's something I would ask the class. Make sense? Okay. You guys like the ship. That's good. Okay, instantiation. So creating objects. This is what we're talking about here. And I promised I'd talk about this, and here it is. One of the best ways to get an object is to ask another object to give you one. Okay? And we've already done this. We did string by appending string. We asked a string, please go append this other string onto your, make a new string that is yourself with this other thing appended onto it and give it back to me. So we asked a string to create a new string for us. A number of objects in iOS have a method called mutable copy, right? We know that NSString is immutable, but it is possible to send it the message mutable copy. It'll create a new string that's mutable, different class, mutable string. Okay, same thing with arrays. And there's even complicated ones like NSArray has a method called components joined by string. And you pass a string like a comma or a space, and it will return a string with all the array's elements, the description of them, concatenated together. Okay? So it's creating a string for you, creating an object for you from the contents of the array. All right? So this is an obvious way. Not all objects that you get by talking to other objects are created, of course. If the object that you're asking for already exists, it'll just give you a pointer to it. So in an array, if you say, give me the last object, it's not going to make another object. It's going to give you a pointer to that object that's in the array. By the way, this is a good time to say, all the objects in an array are pointed to strongly. If you put an object in an array, it's strongly pointed to. Okay? So until that array goes away, or if it's a mutable array, you remove the object from the array, that object is going to have a strong pointer to it. Okay, and that's true of all the classes, array, dictionary, all those strong pointers. So anyway, so not all objects that you ask for from other objects. It's basically if its object was already around, it just gives it to you. Okay? And one of the primary ways to get new objects is to use class methods, like string with format. Okay? Or if you wanted to create a button in code, which you almost never do, you usually drag your button out into your storyboard, but if you wanted to create a button in code, you can send a message to the UI button class. You'd say open square bracket UI button, button with type, and it will give you back a new button. It'll create a new button for you. So this is, you know, probably most of the objects you get by asking other objects or classes to create them for you. But what if you want to create an object from scratch? Okay? And we did that in our walkthrough twice. And the way we do that is with this alloc init combination. All right? So alloc is a class method in NSObject. And what it does, makes space in the heap big enough to hold all the instance variables of the class that's receiving the message alloc. Okay? It allocates no space, sets it all to 0. That's where you get all your nil things starting off nil. That's what alloc does. But, most objects, well, I don't know if I say most, but a lot of objects, if you created them and they're all 0 like that, they're not ready to go. They need some initialization. And whether an object needs initialization or not, we always, 100.0% of the time, wrap init, or some form of init, onto the outside of the alloc. So we get the alloc back from this class method, and then we send it init right away, or init with something. And you'll see that you can have multiple kinds of init methods, all right? So we always do it nested like this, always. That's what we did in the walkthrough, and you always do it in this class. Never say alloc by itself. And then on another line, even the next line, do the init. Always nest them like this, always, okay? So heap allocation is done by NSObject, and the init method, in other words, just plain init, those 4 letters, init, most, if not all classes, implement init sensibly. In other words, if you send alloc init with no arguments to most classes, it will work. And in fact, I believe the way the documentation is written, that if your class doesn't work to just be initted with init, you're supposed to raise an exception, okay? So you want to design your classes so that they can have defaults such that someone can do alloc init and get a valid instance of your class, okay? But you are allowed to have other inits. You can have as many inits as you want. For example, UIView. UIView is the class that creates a rectangular area on the screen for you to draw in, a very important class. UIButton inherits from it. UILabel inherits from it. You're going to, next week, write your own subclass of UIView, so you can do some drawing on the screen. It has an initializer called initWithFrame, and it takes the rectangular area that we're going to draw in. Now, you can also send init to a UIView, and you'll get a view that's 0 by 0 at location 0, 0. Not super useful, but you could come along later and set its frame, and then it would start being useful. So it has 2 inits, init with frame and just regular init. And look at NSString. NSString probably has over a dozen inits. Init with characters, init with format. Init with format, the method string with format probably just does self alloc init with format, the arguments, okay? And then there's init with data, where you can just give it a raw data and tell it what encoding that data is, like ASCII or ISOLATIN 1 or ShiftGIS or Unicode or something, and it can turn that into a string. Okay, so these are all just inits, and all of these you would say alloc and then call one of these inits. Now there's a little bit of a trick here with init, is that all classes have to designate one of their initializers to be what they call the designated initializer. This is the initializer that if you subclass that class, you need to call in super to get your superclass initialized. Okay? Because when you create a subclass, you're going to create your own initializers. All right? And when you do, you need to initialize your superclasses, instance variables, and all that stuff. And you do that by calling this one initializer. And it's important to know which one this is. For like UIView, its designated initializer is initWithFrame. So if I subclass UIView in my designated initializer, I need to call super initWithFrame. Otherwise, the view won't get initialized, my superclass won't get a chance to initialize, right? And I don't want to call any other init that view has. I want to call its designated one. So this is a documentation thing. You have to look in the documentation when you're subclassing something to find out what its designated initializer is and call it from your designated initializer. All right? Now we're going to talk about what your other initializers, your non-designated initializers, what do you call? We're going to talk about that in a couple of slides. Notice that these initializers are not statically typed. Do you see the return type of all these inits? It's not parentheses UIView star initWithFrame. It's ID. Okay? And for subclassing reasons, we always have our init methods return an ID. Okay? Just do it. You might be tempted not to do it, but you should just do it. However, when you have a local variable or whatever, and you're assigning the result of initializing, that should be statically typed. So see, I have obj right there. I don't say ID obj equals alloc init, even though that init returns an ID. I say my object star obj. That way the compiler can start making sure I don't send anything bad to obj. And we're going to talk about this in a moment, but you can assign IDs to static things and static things to ID back and forth. Okay? It's legal. Did you have a question?
Yeah, how do you designate the initializer?
The question is, how do you designate your designated initializer? Documentation. You just document it. You say, this is my designated initializer. Many classes, their designated initializer is init, right? But some classes not, yeah.
What's the design rationale for only having one subclass initializer?
So what's the design rationale for having one designated initializer? Okay, I'll explain it now. So when you think about it, you don't want to create a loop, all right, where I have one of my initializers, it calls some random initializer in my superclass. That initializer calls self some other initializer, right, because it wants to share code initialization with some other initializer. That one calls self, and that thing that it calls self to, maybe you override it. So now you've gone in a loop, and you're just going to go round and round and round. So by designating it, all of your initializers come into the middle, call your designated initializer, and then you go up and call your superclass's designated initializer, and then it goes up and up. Does that make sense? So anyway, static type, we got that. Creating your initialization method. So here's how you create your own init method. Now, you were probably a little anxious to do this last week, right? Because you're used to, in other languages, C++, you got constructors, or in Java, you got initializers like this too, and you wanted to initialize stuff in a class. It's very common to want to do that. Now, in Objective-C, we don't use it that much because we have properties. So we can lazily instantiate a lot of stuff. We don't need an initializer. We didn't need an initializer in our calculator brain. We didn't have an initializer in our view controller either. Okay, and that's common to not have them. But if you do want to have them and you want to initialize some state, this is what it looks like. So this is my object. It's designated initializer. Okay, this is my object's designated initializer. It's init. We have this very funky line of code there, self equals super init. And probably some of you are freaking out to see that because self equals, you're like, whoa, self, no, that's some kind of magic thing. I can't say it equals something. In Objective-C, self is just a pointer, a local variable basically that's a pointer to yourself. However, you never want to set it to anything except for in this case, your init. Now, why do we set self there? It's kind of a convention or mechanism so that we can make sure that our super got initialized before we start initializing. And if our super didn't initialize, we're going to return nil. So if in your initializer, you for some reason can't initialize this object, maybe you depend on a database that's down or something like that, although that'd be bad design. But if you can't initialize, you can return nil from your init. Okay, that is allowed, frowned upon, but allowed. So when you're subclassing, you have to be able to check and see if your super returned nil. So here's my designated initializer. I'm calling my super's designated initializer, which is init. And then I'm checking to see if that returned nil. And if it didn't, then I'm going to initialize myself. And then I'm going to return myself. Okay? Everyone cool with this? It's a little goofy, but that's the way it is. Question?
Is ID type def to void star, or what is it?
So the question is ID type def to void star? And the answer is no. ID is a built-in type in Objective-C. Okay? The compiler knows what ID is. And it acts a lot like void star, right? Because a void star is a pointer to memory. You don't know what's in there. Could be anything. However, the compiler syntactically knows what an ID is. And so it can do things like, check when you send a message to it, right? If you tried to send a message to void star, the compiler is going to say, void star, that's not an object. But if you try to send a message ID, it's going to know that's an object. It may not know what messages that object responds to, but at least it knows it's valid to send some messages to it. So anyway, so that'd be my designated initializer. Here's an example of a convenience initializer. This is not my designated initializer. It's just a convenience. Let's say I will allow my calculator brain to be created with an array of valid operations. So I can create a calculator brain that only works with plus and minus by passing an array of operations in there. Notice in this one, I called it init with valid operations. It's not my designated initializer, so I don't call super, my super's designated initializer. I call my designated initializer. Got it? See, self equals self init. I'm calling my designated initializer from my convenience initializer. That's why I'm saying all these other inits that you have are all going to go to your designated initializer, where you can do common initialization, and then you're going to go up to super. Okay? So self equals self init. All right. Dynamic binding. All right, so this is something specific to Objective-C. Not a lot of other languages have this. Some do, some don't. You're already familiar with the fact you've got these two different kinds of object pointers. You've got statically typed ones and ID, and you know that there's no difference from those at runtime. They're only different in terms of how Xcode and the compiler can help find bugs for you. And you know that you would never use ID star. That doesn't really make any sense because that would be a pointer to a pointer. And people say, well, what if I had a C array of IDs? Okay, yeah, but we're not going to do that in this class, okay? We would usually use an NS array if we wanted an array of IDs. But anyway, so the decision about what code gets executed is happening entirely at runtime, okay? You can imagine, because it's true, that open square bracket, pointer to an object, method, gets turned by the compiler into a C function. Let's call it objc message send. And objc message send has a first argument, which is a pointer to an object, a second argument, which is a message descriptor, basically, and then the rest of the arguments are the same as your method. Okay? So imagine that's what happens. And then when your program runs, okay, whenever a message send happens, this objc message send function gets called. And the first thing it does, it looks at that object to see what class it is, what type of object it is, and then tries to find a method that that class implements. And if that class, and none of its superclasses, implement that method, it crashes, raises an exception. Okay? So you can see how that process, it doesn't matter whether it was an ID or an NS string star or what that originally was in the code, objc message send is going to look at the class at the time of at the runtime, okay? Time the message is dispatched. Okay? So static typing is just for your bug finding, essentially. It is legal and sometimes the right thing to do to cast, and we'll talk about that in a second. So this is a little bit of a review of polymorphism and inheritance here. Hopefully you all know this, but I'm going to throw it up here anyway. So I have two classes. One is vehicle. It has one method, which is move. Vehicles can move. And then I have another class, ship. I know you love ship. And a ship is a vehicle, so it can move, but it can also shoot, right, using its photon torpedoes, presumably. So I'm allocating a ship right here, and I'm sending it shoot. Everything's good, right? Got a ship, statically typed. The compiler knows, of course, ship does shoot. And now I'm sending it move, and that's perfectly fine too. Compiler knows that a ship is a vehicle. Vehicle implements move. Woo, we're good. That's called inheritance. Can I do this? Vehicle star equals V equals S? Of course I can, because a ship is a vehicle, so I can create a pointer, which is a pointer to a vehicle, and I can put a ship in there. And so can I say V shoot? No. Okay, do you see why I can't say V shoot here? Because V is a vehicle. Vehicles don't know how to shoot. The fact that that pointer actually points to a ship, which does know how to shoot, there's no way for the compiler to reliably know that. Okay? So it's doing its type checking based on the static type of the pointer, which is a vehicle. So while this would not crash at runtime, this would work at runtime because V contains a ship, and a ship understands shoot, so it would not crash. It would actually shoot. The compiler will complain. All right, so let's say I had an object, just object of unknown type, and I sent it shoot. Would the compiler complain? No. Okay, as long as the compiler can find that method anywhere, it's not going to complain. It's going to assume you know what you're doing with ID. Compiler always assumes you know what you're doing with ID, so it's not going to warn you. Okay, and there's no way for it to know what that pointer actually points to, because you know this is code. It could be all kinds of loops, and who knows what's making that thing be assigned. All right, so that would not give an error, and it might or might not crash at runtime, depending on whether that object, whatever class it is, understands the message shoot. What if I said object, some method name that no one responds to? Okay, some random garbage. That it would complain about, because the chances that obj really implements that method is next to nil. Okay, no pun intended. So some method name blah blah blah, the compiler is going to complain, which is good. So if you type a syntax error or you mistype a method, usually it's going to catch it, which is nice. All right, so let's say I have a string. Okay, I got in a string star hello, and I assign it to a constant string hello, and I say hello shoot. Well, that's definitely going to fail, and the compiler knows that's going to fail, so it's going to warn you, and so you'll avoid your crash at runtime there. But what if I cast it? What if I say ship star hello ship, so that's a pointer to a ship, equals casted ship star hello? Okay, compiler's going to let me do this. It assumes that if you're casting, you know what you're doing. Now, of course, the next line, hello ship shoot, no warning from the compiler, crashes at runtime. Because, of course, string does not implement shoot. Okay? And then, finally, if I casted hello, which is that string, to ID, right in line, and casting in line is allowed, and said shoot, that would also not generate a warning and would also crash at runtime. Okay? All right. Let's see, what do we got here? Introspection. Okay, so we got this ID. It's dangerous. It can crash our program. What are we going to do? We're going to use introspection. Okay? And so using ID is not always bad. We know, for example, that having an NS array that you can put an object of unknown type in is great. And some people, if you're used to Java, in Java you can essentially have template classes where you can say, this is an array of strings, and the compiler will make sure that there's only strings in there. But what if you wanted an array that had some strings in it and some NS numbers mixed in there? Okay? And we're in fact going to do that on Thursday. All right? And in that case, it's really nice that NSArray takes an ID. So there are good things. Also, what if you had something, an object that was private to you, is your private implementation, and you wanted to give that object to people, but only so that they could give it back to you later and do something to it. But you don't want them to know what class it is. All right? So you make it ID. It's like a cookie then. Right? So there are reasons to have ID. But we need to be able to find out what class something is in our code, of course. And so there are a few methods to do this. I'm going to talk about these three: is kind of class, is member of class, and response to selector. Okay, the difference between is kind of class and is member of class is inheritance. All right, is kind of class will tell you if it's that class or if it inherits from that class. Is member of class tells you, is it that exact class? So if I said, is this calculator brain a kind of class NS object, it would say yes, because a calculator brain is kind of class NS object. It inherits from NS object. But if I said calculator brain is member of class NS object, no, because calculator brain is a member of the class calculator brain, not NS object. Okay? And then response to selector, a little bit different animal. That is, does this object respond to this method, regardless of what its class is? Okay, so both of these are useful tools in your bag of tricks to work with ID. The arguments to these two methods are a little bit tricky, so it's kind of a take my word for it. Here we have is kind of class, and the argument to it is a class, actually the same kind of class that we were talking about when we talked about class methods, but you can't syntactically say is kind of class colon NS string, close square bracket. Okay? NS string, when you type it in there like that, is really just a mechanism for sending a message to the class. So you need to use that class method. This is the class method class being sent to the class NS string to get its class. Got that? That's why I say just take my word for it. But anyway, so this is the form you use to find out if something is a string. Say object is kind of class, square bracket, and a string class. Okay? The selector thing is a little bit different. A selector is the word we use to describe a method in Objective-C. And so we use this magic @selector syntax. And the way @selector works is you just say @selector parentheses the name of the method. And when you put the name of the method, obviously you don't put any of the types of the arguments or the argument names in there. You just put all the keywords and the colons. All right, so look at the second one, for example, shoot at colon takes one argument, shoot at, and it's, probably it's an object or something. But in any case, you see object response to selector, shoot at colon, then you can send that message and it won't crash. Okay? Notice that the types of the arguments are not encoded here in the @selector. So if you had the same selector that had different argument types, that could be a little bit of an issue, so don't do that. Okay? There's a type def in Objective-C to hold a selector. So the @selector, the thing that returns, you can put it in a variable. It's a variable of type SEL, which is a type def. It's probably some big int, a 64-bit int or something like that. And if you have a selector lying around, or if you call @selector, there's some pretty cool methods you can call. For example, in NS object, there's a method perform selector. And it'll perform a selector that has no arguments. There's also perform selector with object. That'll perform a method that has one argument that is an ID, or any type, right? Any object type. Sorry, any object type. Also arrays. You can ask an array, make all the objects in yourself perform this selector, which is kind of cool feature. And then, of course, target action uses this. UI button has a method that it inherits from UI control called add target : action : and there's some other arguments. And so you can say button, you have an instance of a button, you say button add target : self. The action is @selector digit pressed : Okay, so that would be in code. We could set up that same target action we did with control dragging in our storyboard. Everyone understand that? So that's selectors. Okay, so we have enough time, I think, 16 or 17 minutes here, to cover Foundation. All right, so Foundation is a framework, has a bunch of really important objects in it. You already know what some of them are, and you've used some of them, and so we're going to get a little bit of the skinny on them here. Let's start with NSObject. NSObject is the base class for pretty much every class you'll ever going to use or create in iOS. Okay, it doesn't have a lot in there. It has +alloc, of course, that class method that allocates space for it. It has all those introspection methods, response to selector and is kind of class. It has description, which we used to create the description of an object so we could NSLog it to the console, for example, and usually classes override description to provide a nice description of themselves. It has methods copy and mutable copy. When you look in there, you'll see that, and you'll be like, oh, cool, I can copy any object by sending copy to it. And the answer is no, you can't really do that, because for copy or mutable copy to work, the class in question has to implement a certain protocol, okay, to copy themselves or to make a mutable copy of themselves. Luckily, a lot of the classes in Foundation, like arrays and stuff, implement that protocol. If you want to know whether an object can do copy or mutable copy, you want to look in its documentation and see if it conforms to the protocol copying or mutable copying. Okay, and we haven't talked about protocols. We'll talk about those a little later. But if you see an object and it implements that protocol, then it can be copied, immutable copy, or mutably copied. Make a changeable copy. Okay, question?
Is that a recursive copy?
The question is, are these deep copies? In other words, if I copy an array, is it going to copy all the items in it? And the answer is no. This is shallow copy. Some objects have a deep copy, but this is shallow. Okay? Good question. All right, NSString. So this is your most popular object in all of Foundation. Okay, we use this a ton in our walkthrough, and we use it all over our code. What is an NSString? It's a full international any language string, and I mean kanji, Cyrillic, Arabic, English even. So any of those can be coded into an NSString. It uses Unicode under the covers. It's quite an awesome complete implementation of that. It's used throughout iOS instead of CareStar. We do not use CareStars. There's maybe one place you'll see in this quarter where we use a CareStar for a pretty low level API. You know that the compiler will create an NSString for you on the fly using that @quote syntax. NSString is immutable. It cannot be modified. If you want to modify it, you either have to get a mutable version, which I'll talk about in a second, which you probably don't want to do, or you just ask the string to do whatever you want to do to it, and it'll give you a new string with the result of having done that thing to it, like appending a digit onto it. Okay? So the normal usage pattern for a string is to send in a message, like we did with self-display.display.text equals self-display.display.text, string by appending string digit. Or a class method, same thing, right? We are creating new strings. They're immutable. Once they're created, we can't change them. So we create them the way we want them. There are a ton of utility functions in a string. I gave you some examples up here of what they can do. I really strongly recommend you go look at the documentation for NSString and familiarize yourself with the kinds of methods that are in there. Because there are methods in there that do so much with one line of code, you would not believe it. And it will save you writing 5 or 6 or 7 lines of code to go just use an NSString thing that does it for you. Okay? That's true in array as well. Those two classes, array and string, you really want to know all the things they can do, because they can save you a lot of code. All right, so the mutable version of string, NS mutable string, it does do, not most, it does some of the things that NS string can do by creating you a new string in place. So we could have done, for example, the appending string with a mutable string. But why don't we use mutable string? And students really want to understand, mutable string seems so great. I can, I don't have to create a bunch of new objects all the time. But you got to remember that if you are creating a string, a mutable string, and you're like appending onto it, you might well be going back to the heap and allocating more heap space and copying characters over and all that stuff, just like you would if you were creating a brand new string object. So you're not necessarily saving that much heap thrashing by making a mutable string and modifying it in place. What's more, NS string, the immutable one, is optimized to the nines. I mean maximally optimized to have as little heap thrash as possible, super efficient. It has memory pools and things it manages inside that make it so that you can do immutable strings, not even worry about performance. So it is rare, quite rare, that you would use a mutable string. Okay? You're much more likely to send a message to an immutable string asking it to give you a different one. Okay, so some other random objects before we get to array and dictionary and set, which are kind of the collection, the classes there. Let's talk about some random objects. NS number, you already know about that one. Wraps a primitive type. And it does type conversion for you, so if you wrapped an int and then you ask for the float value, it'll convert it to a float, and vice versa. Okay, truncate floats. So that's NS number. There's NS value. NS value is, there's a select number of really important structs in iOS, like CG point and also CG rect and some other ones. And NS value is an object that knows how to wrap those into an object. So you could put a bunch of points in an array using NS values. Okay. NS data is a bag of bits, unstructured data. It's just bits and the length, the number of bytes worth of bits in there. And it's up to the API that you're passing the NS data in or out of to interpret what those bits mean. Okay, they might be a string in there encoded with some encoding. There might be an image in JPEG or something. And if you pass that to the UI image, then you get an image, etc. So it's just bag of bits. And then there's NS date as well, which is the date and time, current or past or future. And there's a lot of NS calendar, NS date formatter, things like that for formatting dates and parsing dates and all that stuff as well. All right, NS array. Probably the second most popular object in Foundation after a string. It is an ordered collection of objects. It automatically grows and shrinks as you add objects into it, just like an array, an object array in any other language. It's immutable, however. So you might say, well, wait a second, you just said it can grow and shrink. Well, I mean, when you create it, it will make itself the right size and stay that size. And if you had a mutable one, which we'll talk about, it would grow and shrink. Okay, that's what we use in the other one. So NS array is immutable. Same reason it's immutable as NS string. One other reason, by the way, to have immutable objects. Imagine you're passing objects around between other objects through their API, and you passed a mutable thing in, like a mutable array. And then later, you added something to that mutable array. Well, would the object that you passed the mutable array to earlier, would its array get modified? If so, that's really difficult for that object to deal with. It wants an immutable snapshot, basically, of the array when you pass it in. And so that's one good reason to be having immutable arrays all over the place and only having the mutable arrays when you really need the mutability, and it's usually internally only. Same thing with mutable strings. You want to pass strings. And in fact, you'll see most of the string API in iOS is @property parentheses copy, okay, which we haven't talked about, which is just like strong, except for it makes a copy first, an immutable copy, and then keeps a strong pointer to that immutable copy. Okay? So immutable is the way to go, both arrays and strings. So if you got an immutable array, how do you put anything in it? Well, you do it at creation time. And there's quite a few class methods to create an array. Here's one called array with objects. It's one of these ones with a comma that you can specify as many objects you want. It's just a nil terminated list of objects. So if I wanted to create an array with the primary colors in it, I could say open square bracket NS array. It's a class method. Array with objects. And then I pass 3 string objects and nil, and now I've got an immutable NS array with those 3 objects in it. Okay? There's also array with object. single object. And you might say, why do I need that? Well, you might have an API that can take multiple objects, but often only takes one. And so your API takes an array, and people use array with object to pass one of those things in. The main two methods in NSArray are count and object at index, obviously. Count is the number of objects in there. Object at index gets you the objects at that index. We know about last object, which is a nice convenience method. And it has a ton of other methods. And like I say, you got to go look at these because it can save you a lot of code. Yeah.
Is it possible to store nil as a value in an array?
So the question is, can I put nil into an array? And the answer is no. There is an object, however, called NSNull, which you could allocate in an int and put in there. Okay, but you can't put nil in an array.
And how does NSNull work?
It's just as placeholder. How does NSNull work? The question is, it's just a placeholder for a blank thing. Contains object is probably slow in an array. Okay, especially if the array is big, because it doesn't know how to look for things in there. So you probably would want to use something else, which I'm going to talk about, which is an NS-ordered set, or a set in general, if you want to find out membership. Okay? Okay, mutable array is the mutable version. You create it either with the class methods for array, like you could create a mutable array that starts out with red, green, and blue in it, and then add more to it. Or you can use one of these two. Array just creates an empty array. An array with capacity, don't get confused by this. This is just a performance hit. This is still creating an empty array, but it's giving you a performance hint of how many objects I'm likely to add to this array soon, right, in the near future or in its lifetime. So it's just performance hint. Use it if you want. Don't worry about it if not. The main methods in a mutable array, of course, are add and insert object and remove object. Exactly what you would expect. There's that remove last object, which is a convenience method to do that. We use that. Don't forget that copy on a mutable array returns you an immutable array. And mutable copy on an immutable array returns you an NS mutable array. Okay? So you can go back and forth by creating a new one. And you might be kind of scared, whoa, it's going to copy my entire array just so I can make it immutable or mutable. It's quite efficient to both make an immutable copy of a mutable array. Not so much to make a mutable copy of an immutable array. That's not quite as efficient as the other way around. But still, these things are super optimized. And don't forget that NSArray, mutable array, inherits everything from NSArray. A lot of times people forget that. There's a lot of cool methods in NSArray that you get in NS mutable array. All right, so now let's talk about dictionary. Dictionary is a hash table. You create it with its class methods. Here's an example one called a dictionary with objects and keys, which is just a list of object, comma, key, comma, object, comma, key, comma, nil. Okay, as many as you want. This is immutable, so if you want to have objects in this dictionary, you got to do it at creation time. The two important methods are count, tells you how many keys are in the hash table, and object for key, which takes a key, looks it up in the hash table, returns you the object. Okay? You can also, for example, get all the keys or all the values as an array. There's a bunch of other methods in NSDictionary. Not quite as important to know those as NSArray and NSString. The keys are sent hash, this method hash, which is an NSObject method, and is equal in order to identify them. It's a hash table after all. NSObject returns the object's pointer as its hash and is equal if the pointers are the same. But most times you're going to use something like a string as your key into the hash table, and strings hash based on the characters in themselves, and they're is equal if the characters are the same, even if the pointers are different. Okay, so usually string is the most common key, but you could use another object as long as the objects are unique by pointer. NS mutable dictionary, if you create it with dictionary, it adds the two methods set object for a key and remove object for a key, as you would expect. You can remove all the objects. You can, if you have another dictionary, immutable or not, you can add all the entries into it exactly as you would expect. NS set is an immutable, unordered collection of distinct objects. So all those words matter, okay? It's unordered. There's no object at index like an array, okay? It's immutable, just like arrays and strings, and it's distinct. You cannot put the same object in twice not just an object with the same pointer, the same object that is equal to an object that's already in the collection. So this is the thing you want to use if you want to check for membership. If you want to see, do I already have this object, for example? You put it in the set, and you can check to see if something's in the set. Why would you have an immutable set? Again, you might have an immutable set of all the colors, and then someone types in a color name, and you ask the set, is this a color? By asking if it's in that set, right? And since it's going to do is equal on that color string, it's going to work no matter where the strings come from. So you create it as you might expect. Count and contains objects are the two key methods in NSSet. There's a method anyObject, which is nice. You just grab any old object out there. A lot of times you have a set of related objects, and any one will do for some certain operation. So you can say anyObject, and it'll very efficiently return any object. And you can make all the objects perform certain selectors. There's a mutable version. It adds remove object and add object. Notice no insert object at index. This is unordered. Okay, there's no order. It's just a bag of objects. If you call add object, and there's an object already in the set that is equal, it will do nothing. Okay? You can also union and intersect and minus sets. Okay? So if you want to do set arithmetic, you can do that as well. And then there's NS-ordered set. So NS-ordered set is not a subclass of NS-set, but it's kind of a hybrid between an NS-array and an NS-set. And so it does let you do index of object and object and index. However, again, you cannot put the same object twice in. That's the difference. So contains, doing membership checking, is quite efficient with an NS-ordered set compared to an array. However, in array, you could put the same object in 100 times, and it would be at index 0, 1, 2, 3, 4, 5, 6, all the way up to 99. Oh, yeah, by the way, arrays start at index 0, as you would expect. So an NS-ordered set, you cannot put the same object in twice, but it implements contained object very quickly. Since it has order, it can also tell you the first object and the last object in the NS-ordered set. You can also get the ordered set as an array, since it maintains order, or you can get a set that tells what is in the NS-ordered set and lose the ordering. Okay? Mutable ordered set, as you imagine, you can insert objects and remove objects and set objects at index. Okay? Again, if you try to insert an object that's already in the set, it will do nothing. Okay? All right. We're getting close. We've got a couple minutes. We might be a little over, but let's get quickly to enumeration. It's exactly what you expect from other languages. You can do for in. So I can say for ns string star string in my array. Okay? And if array is an array of objects, then string is going to be set to each object in turn inside of the curly braces there. If my array contains non-strings, this will crash at runtime with no warning from the compiler, because there's no way for the compiler to know whether my array contains non-strings when you do this. Okay? So be careful here. So if you had an array that might have other objects in it, you might want to do something like this. Here's a set that I'm iterating through, ID obj in my set. And look, I'm doing introspection inside, okay, to see if it's a string before I send some string thing to it. All right? Enumerating dictionaries enumerates through the keys. And so inside the loop, you can do something with the key, and then you could call my dictionary object for key and get the value. And so you could do something to the value too. Right? So you can do the key, modify the key or the value, or not modify, but deal with. Speaking of modify, inside of for in, you don't want to modify these things. If these are mutable, do not be adding objects inside the fast enumeration. This is called fast enumeration, by the way. Do not modify a mutable array inside a fast enumeration of its objects, okay? That's bad. And actually, the compiler will probably catch that for you. All right, 2 more slides and we're done. Property list. A property list is just a word. It means any combination of NS array, NS dictionary, NS number, NS string, NS date, or NS data. Okay? Those 6. So you could have an array of strings. That would be a property list. A dictionary whose keys are strings and whose values are arrays of dates. That would be a property list. An array of calculator brains, not a property list. Okay? You can only have these things in it. Why do we define this term property list? Why do we say property list? Because we have API in iOS that takes an ID, and the documentation will say, this ID must be a property list. Okay? And that means it's got to be one of these. And for example, what is an example of where we do that? It's NS user defaults. This is my last slide. NS user defaults is a lightweight database of property list items. And by lightweight, I mean lightweight, small. Strings and dates, maybe an array or two, a dictionary that's small, not, images and, gigantic data structures, okay? This is lightweight. This is for things like user preferences. That's why it's called user defaults, okay? It's basically an NS dictionary that persists between launches. So your application, or even between the phone crashing or whatever, when your application launches, it will get its user defaults back to the way they were when you last synchronized it, which I'll show you in a second. You read and write by calling this class method in NS user defaults called standard user defaults. It gives you an object and you send it messages like set array for key. Okay? So it's kind of like a dictionary, but it's got specific messages like set array for key, set a double for a key, set an int for a key, get an integer for a key. Okay? Set an object for a key. If you do set object for key, guess what obj? What kind of obj does obj have to be? Do you think? Right there. Property list, exactly. Bonus points. I can't see you because of that bright light, but you get a bonus point if I could see you. Yes, set object, obj, that obj has to be a property list. Okay, any property list will do there. And then array for key, the things like array for key, if there's not an array stored at that key in the defaults, you'll get nil. So it's not going to crash, you just get nil. Like you stored a float there at that key. Right? The key is just a string, like foo. You store a float there, and then you ask for an array, you're going to get nil. Last thing, whenever you write to user defaults by calling any of these set, this, that, or the others, you got to synchronize it with the disk. This is like save, and you just say NS user defaults, standard user defaults, synchronize. Okay, so you're going to want to do that anytime a little batch of changes, you want to synchronize. If you don't synchronize, your data will not be getting saved. So definitely synchronize. Synchronize is not free, but it's pretty cheap. Okay, so better off to go ahead and synchronize rather than to try to batch things up too much. All right. Next time, we're going to have a demo again. I like to demo everything I show you in lecture. So next Thursday, I will demo all these things, ID and class methods and all these introspection, all that business. And on Friday, we will have, again, a brief section, which is source control. Sorry to go over, and I'll see you on Thursday. If you have questions, I'm here.
For more, please visit us at stanford.edu.